Hi, I'm Chang Lee, and today, finally, we start to learn about the semiconductor fabrication technology. And at first, we learned about the wafer. Wafer has 4 inches, 6 inches, 8 inches, and 300 millimeters wafer and 450 millimeters wafer. Uh, uh, we continue to size up the wafer, and uh, this part of the wafer is die, called die, and if the number of die is increasing, uh, we can uh, sell a lot of products, and wafer size is increasing, and if the wafer size is increasing, the number of die is also increasing, and we can got a lot of money. Uh, why in the industry uh, we do not use 450 millimeters wafer, because if the wafer size is increasing, we must buy a new machine. So 400 millimeters loading equipment will be provided. So and we also change the options. Mm, we use plasma fabrication. Uh, so fabrication of plasma on the wafer surface. Plasma density is important. So at the edge of the wafer is the dense of the um, plasma. So chemical reaction speed is different. So uh, uh, of the center of the density losing part. So we do not use 450 millimeters wafer. Uh, this this causes the gate oxide thickness, and also look at the FinFET, vapor centers, and vapor edge. Uh, so fin's shape is different. Mm, so we do if we do not uniformly fabrication of the uh, semiconductor on the wafer, mm, uh, in the wafer, in the QA part, it will be failed. So fail die. So we do not sell the product. Yield is suyo of Korean. So yield and performance of trade-off is we our homework. So 300 millimeters wafers of uniformly plasma fabrication is difficult. Uh, heat flow costs. So each sections each sections the temperature distribution is different. And chemical reaction is different. So fabrication and device structure is also different. So is the problem. We expect if we expect a large wafer, and it costs a large of number of die, and so about it's difficult to control the fabrication. So number of die can make larger, but proportionally, if the yield is decreased, no 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 net cost is. So now 450 millimeters wafers do not use. This is why we scaling down the device. So device size is decreasing. It caused die and circuit size. It means die and circuit size is also decreasing. It caused number of die is increasing, and we can get a lot of money. mm, we also learn about the node and mm, in the past, node means the gate length like LG, but uh, mm, today's we can tell the um, we can tell the node about the code number of the device. So um, we come into the submicron. Device scaling down is not easy. So, but fabrication, learning or technology is increasing. So scaling down is accelerated. So um, uh, because of the uh, short channel effect, scaling down is can easily in the 2000 in the middle of the 2000 years. So uh, after the 2010, we developed about the FinFET. So uh, uh, scaling down started again. We can consider about the four driving force about the PPAC, area, performance, power, and cost. First area. If the area is decreasing, is the good case. And look like this performance. If the length of the channel is decrease if the channel is decreased, tau equals RC, so resistance R is decreased and frequency F is high. So performance increasing the performance is the good issue. And also look power. If we scaling down the device, scaling down if we must scaling down the device and we decrease the power consumption. So in the direction of the uh, decrease of the dynamic power dissipation, mm, mm, power equals CVDD square F. So we must decreasing the capacitance like out freezing cap, in freezing cap, like overlap cap, such as this. But we must increasing the Cox because we can victory about the short channel effect. Uh, Gate and channels coupling for the good coupling of the gate and channel. So oxide thickness is must decreasing, and we use high dielectric. So we must increasing the Cox, but we must decreasing the other capacitance like overlap cap, increasing our freezing cap. Mm, at last, the cost is also important. Uh, mm, it must cheap about the making total cost of the making device, uh, area decreasing about the area, increasing of the yield. So it costs many product selling. So total cost decreasing and mm, benefit is high is uh, our direction. It's the also said PPAC and for driving force. Mm, uh, in this view, we learn about the contact and contact and spacer. Uh, do not short about the gate drain gate source. We must use SiO2 to spacer to barrier it space, and we must prohibit electrical interference to making the depletion area to like this this area to doping the P plus, and mm, gate contacts, substrate contacts, uh, we prohibit the short. So like this distribution is the design rule, aka PDK. Uh, and finally, we learn about the photolithography is the base, and it tells about it states that selectively patterned is the powerful tool about the lithography.